I'm not sure if I can answer that.
I don't know.
So there's been no change with who can see what on the device registration page. That is remains unchanged, which I believe everyone can actually see it. But generally, it's only because you want to restrict who can register devices. So you don't want to give that privilege to everyone. So it is still an elevated privilege for people who want to register known devices.
Okay, great. And I think there's another question that we'll answer in the chat. So thank you all for the questions and for the answers.
Okay, so I go on with the open source innovation. As Jane pointed out, we just saw awesome product innovation. But besides that, we also have innovation in so-called open source components. One of them we already saw. It's our biggest open source innovation, I would say, Synage. So Ruben already pointed out the highlights of the Q1 already and the outlook, what to expect for Synage. But there are a lot more components we are having in our open source space. Let me highlight a few for you. So first of all, I wanted to highlight is an open source component called Dynamic Mapper. Jane already announced it. It's mainly were developed when we first thought about MQTT service, to having a generic MQTT service where you can publish just any payload, and having the concept that you can write a microservice to do the data mapping from your legacy data format to the Cumulocity data format. And during that time, an open source project was formed so-called Dynamic Mapper. And the idea was, why not doing that in a graphical way? Yeah, and the idea is that you have just single clicks. You create a new connector coming to MQTT service, for example, just one click saying, hey, I want to connect to MQTT service. You don't have to provide anything because it's running on the same instance. Or you can use an external broker, or you can use some brokers like Kafka, or you can even use things like an HTTP endpoint to get data ingested. So this is step one. Step two is then you can snoop on the payload which is coming in. It can be some, JSON or whatever data coming in, and you're seeing what data is received. And you can select that data as so-called source templates. And then just with the single clicks, you can see here highlighted in the screen, you can map your data to a target tablet, which is mainly Cumulocity format, of course. Yeah, for here in this example, we have some arbitrary payload and we're mapping it to a vibration measurement data. This was the intention of the Dynamic Mapper, that you don't need to write a microservice, you don't need to write code to do that, and to have it in a graphical way. So this is the first part of the Dynamic Mapper. And the second part, of course, is you need to manage this kind of mappings. Yeah? So once you have defined your mappings, how to map the data from any format to the Cumulocity data format, you need to manage it. So you want to activate mappings, you want to duplicate mappings and using it as a template for the NAS mapping. You want to manage the mappings for specific connectors only. All this kind of managing is also part of the Dynamic Mapper. Even having some monitoring capabilities that you can see, hey, my mapping is failing because some payload was received with data which was not expected. So the mapping failed. So you can see there are some errors and you need to adapt your mappings. And it was from the beginning designed to be very scalable. So we can handle thousands, millions of messages and very resource efficient in a multi-tenancy way that you can deploy it on an enterprise tenant and subscribe your subtenants to it. And you don't have to subscribe, or you have to have an instance in each tenant and running, but you can share the resources. As I said, this is all open source currently. You can access it on our GitHub account, GitHub Cumulocity IoT, and there we have the Cumulocity Dynamic Mapper. It's, as I said, it's we had some major improvements in Q1, and one or few of these improvements I want to highlight now. This one should actually be hidden. Let's jump to the next one. The first one I wanted to highlight is a new feature which we called HTTP inbound processing for the Dynamic Mapper. As I said, of course, we can use the MQTT service, which is now in the public preview, but also we received the requirement that sometimes devices are sending requests via REST or HTTP. So therefore, we implemented a new so-called default HTTP connector, which is already part of the mapping when you deploy it already, so you don't need to configure anything. And it will provide a generic endpoint, and you can just use the generic endpoint with your custom path. Beyond that, sending any payload, and then it will be then available for creating your mapping. Yeah, so you have your custom payload, you just send it to the HTTP inbound, just do your mappings, and then you see your data in Cumulocity. So this is the first innovation I wanted to highlight. The second innovation I wanted to highlight is actually the other way around. Because we are not able, with a dynamic mapper, we cannot only process incoming data, but we can also send data coming from Cumulocity to some other system or device, if you want to. And here we have enhanced a new feature we called webhook support. Here we have defined a new connector of type webhook. You can configure it with a custom endpoint or system or whatever. You need to provide, or if it's a secured endpoint, you need to provide the credentials. So this is the connector configuration. And then you do the vice versa mapping. Yeah, you're saying, okay, now I'm receiving a measurement from Cumulocity. I do the mapping, I assign it to my webhook, and the webhook will take care that the data is sent out to any system if you like, of anything you can imagine, if it's supporting some custom HTTP endpoint. So it's the second innovation. The third innovation of the mapper I wanted to highlight we did in the Q1 was that we received the feedback. The visual mapping is good. The expression language we're using there is also good, but sometimes for very complex mappings, I would wish that we have some simple script language where we can do the mapping. So what we have done is we have implemented code-based mapping. So you can decide on when you create a new mapping that you say, okay, now I want to have a visual mapping, or I use the code-based mapping. And what you get if you select the code-based mapping is in plain JavaScript. Yeah, so we're providing a function which is called extract from source. Then you get the context of the message which is received, or the source template actually, and what it is expected that you do the mapping with your JavaScript code, and in the end you need to return result with all the mappings and replacements and so on. So this is the code-based mappings. Herefore, we implemented some templates. So inbound mappings, outbound mappings, we have a concept like shared code. So for example, you have some common functions, decoding functions, which is used across multiple mappings. Then we have a function called shared code. You can put that function in there. And in your mappings, you can just call that function, which is defined in the shared code. So this is I would say, quite big improvement we did. The second improvement, or the fourth improvement of the dynamic mapper I wanted to highlight is advanced message filtering. We received the feedback that, okay, I have a topic now where data is sent, or the path in the HTTP inbound case, but sometimes I do not want to process all the data, because sometimes it's the same topic, but the payload looks differently. And it needs to filter out the data. So what we have implemented is so-called message filtering. So on the source template, you can decide with an expression language if this mapping should be executed or not. In this example, you can say, okay, so this mapping to be executed, a temperature fragment must exist, or temperature object must exist in the payload, and the value of the temperature must be bigger than 50. So all messages where the temperature is below 50 will be dropped and will not be mapped, but all the messages for temperature values higher will be mapped. So this is the first improvement for the advanced message filtering, but also received feedback, hey, it would be nice if we would just create measurements, but sometimes the measurements are related to the device where the measurement should be sent to, especially for the outbound part sometimes. So can we also filter on some fragments on the device? So we have some inventory filter also that you can define and saying, okay, I want this filter for the message, but also only for devices of type LoRa device type in this example. Yeah, and this is working in both directions, inbound and outbound. So you can define that filter for incoming message and messages coming out of Cumulocity sending to somewhere else. So this is the first component I wanted to highlight, dynamic mapper. I would ask you to try it and give feedback. It's an open source project, so you can just write issues if you find something. The second component I wanted to highlight as an open source innovation is the field service management. The field service management is a microservice and some UI plugin that allows you to connect Cumulocity Cockpit with existing field service management solutions. Yeah, so the microservice can connect to a field service management solutions, or if you don't have a field service management solution in place which you want to connect to, it also provides a very basic field service management capabilities that you can create service requests in the cockpit, and then it will be stored in Cumulocity, and you can handle it and have some kind of process. The innovation in Q1 was actually that we introduced a new component as an analytics builder blocks, which is now available also open source, and you can use that. So as I said, in the first you could use in the cockpit, you have a plugin where you can manually create the service request. And the new innovation is now that you can automatically do that with using analytics builder. On an alarm or on some threshold values, you can automatically create a field service request using the analytics builder blocks. So this was the second innovation I wanted to highlight. And the last innovation I wanted to highlight, open source, is a very common and well-accepted tool, which was mainly developed by Ruben. It's called the Cumulocity CLI. In Q1, we had major improvements here with 2 releases. I wanted to highlight a few new features we had here. The first one we already saw is that we have in Cumulocity now, I would say, a big game changer in how we can register devices, and the CLI has been adapted accordingly. So you can not only register devices using username and password, but also, of course, certificate-based, but also, of course, using the Cumulocity certificate-based authentication. So the CLI has been adapted. Then there was a new feature that you can easily change the toggles between, for some features we're using toggles, feature toggles. Here we have now support in the CLI that you can easily use that. For the better error handling, it was improved that now full errors are printed out if we have some issues, so for easier troubleshooting. Also, we had a new innovation that the tenant management, especially for enterprise tenants, where you want to add or remove tenants, disabling tenants, there was quite a big improvement how you can do that also using the CLI, but not in the user interface. And of course, there will be a lot of user experience refinements, documentation fixes, and so on. If you haven't used it, I strongly suggest to try it out. It's a very powerful tool. Aaron also mentioned that we have a full local proxy install, part of this Go CLI for the remote access. There you can very awesome stuff with the Cumulocity CLI.